Okay, wow, this is take two, believe it or not. I totally messed up on the last one, but you missed it. It was really hilarious. No, it was boring. Okay, anyways, we're looking at inductive reasoning, which is basically analyzing patterns to try to figure out kind of what the pattern is, and in this case, to express it numerically in some kind of equation. So I think if I told you to, you could spout out the next two numbers of this series pretty quickly. So why don't you do that right now? Say them out loud, I'll listen for it. Very good. I heard you all. Don't worry, I can't see you. And creepy. Anyways, so there is the next two numbers in the pattern. And so if you wanted to describe it with an equation, you might be tempted to do something like this. Just say y is equal to 2x because we're just doubling a number all the time. But if I plug in, what do I plug in for x and y? Is the first term, do I go 2 times 1 is 2? No, that's not it. But 3 times 2 is the next term. So I have to rewrite these numbers in a slightly different way in terms of n, or the position in the line, like the first, second, third, or fourth number. So let's make a little bit of a table. It's going to look just like this. Okay, and so I've added a column for n, which is the position in the sequence, first, second, third, fourth, fifth, sixth number, and the actual term, the number, 3, 6, 12, 24, 48, 96. And I want to write an equation to get the number if I knew what the term was, or vice versa. Okay, so to do that, we have to first of all look at that sequence of numbers in terms of what am I multiplying by, and how is it somehow related to n. So let's first of all look at how it's multiplied throughout here. So the first one there is 3 times 1. The next one is 3 times 2. And oh, maybe we're on to something. This is going to be 3 times 3, but it's not. It's 3 times 4. Then this is 3 times 8. And this is 3 times 16. But there's the pattern that we're getting, right? We're doubling the number we're multiplying by every time. 3 times 48. 3 times 32. Okay? So we have to figure out that number. It's going to be 3 times something, and that something is changing in a regular pattern. So how can we write 1, 2, 4, 8, 16, 32 in terms of n? And hopefully you might be able to recognize that a lot of those are actually powers of 2. For example, this is 3 times 2 to the power of 1. 3 times 2 to the power of 2. This is where recognizing patterns and being a little bit creative helps you to kind of figure out this whole process. Here are the rest of them. And then, of course, working backwards, you get the last one. And now our task is, we have an equation. 0, 1, 2, 3, 4, 5 are the exponents in our equation. 3 times 2 to some power. How can I relate 0, this number exponent here, to n? How are they all related? And so now you can see it's a pretty simple relationship. It's always just one less than the number. Okay, so in other words, my equation is going to be t, the actual number, is going to be 3 times 2 to the power of not n, but n minus 1. And that'll take care of it for us. Okay? So the process is a little tricky, I get it. So let's look at a different one and see how that one goes. Okay, look at that pattern there. See if you can name the next two numbers. Yeah, exactly. We're just going up by 6. Pretty simple, okay? So again, let's do the same thing though. Write a table in terms of n so we can make an equation. Okay? So the first number is 2, second one is 6, or sorry, 8 rather. Okay, so let's sort of figure out how we know that we're adding 6 every time. So how can I make that into an equation? So again, I'm going to write this column here, this row here rather, in terms of the number I'm constantly either adding or multiplying by. In this case, it's adding. Okay, so there we are there. I'm adding 0 to 2 and then 6 to 2. Oh, that should say plus, not times. Okay, and you get the idea. And you can sort of see that these are all multiples of 6. 6, 12, 18, 24. Okay, so I can write that as a multiple of 6 in this fashion. Okay, there. And you'll notice I'm kind of leaving the first one alone because sometimes it's hard to see that first one. But then this is going to be 2 plus 6 times 3. Okay, and working backwards, 2 plus 6 times 0, which is 0, and therefore you get 2. Okay, done. So again, looking at this relationship here, look at that. There's always one less. That's not always going to be the case, but it is right here. So what's the equation? The equation? The occasion. The equation is your homework, silly. Okay, here we go. So it's 2 plus 6 times, not times n, but n minus 1. All right? All right, let's pause there and look at the next video.